All right, so question 3 of October November 25, paper 4-1. So as we discussed, this is a simple hash table question. So they have given you a 2D array, and then they're saying there are records stored at a specific index. Okay, so
If here is
yes, so we have records here, and then we're supposed to store the records in our hash table. All right, so the question is very straightforward. They have given us an array with 100 by 10 elements. So we have 100 rows and we have 10 columns from 0 to 9. And they're saying that if any two key fields would generate the same index, then that is the collision, which means you cannot store two values at the same index. So you will have to basically go to the next available space, just like we do in linked lists, just like we do in binary trees. They keep on looking until find an empty space. So in this table, two record keys generated the same hash value of 1. So we stored the first record at 0, and then we stored the second record at the other spot. So four record keys generated the same hash value of 3. So 1 went to 0, then 1, then 2, then 3. So this is the process that we call chaining in hash tables, and this can sometimes be asked in paper 3 as well. So you guys should be well aware of these terminologies. Okay, then in the next part, they're asking that you have to use object-oriented programming to implement the record. So it will have two attributes, key and data. It will store the integer value, and data would be a string value, and we have to assign parametric values. They would be public, and we need to write the constructor. So this is going to be very simple. So let's call it record class record, and then we'll write define init dash dash self, and then they're saying attributes are public. Okay, since they're public, we're not going to put the dashes here, so we'll just write self dot key is equal to, so we'll have two parameters here, ky maybe and dt. So is equal to ky, and then self dot data is equal to dt. We have to use the same attribute names as given, including the case sensitivity. So let's declare this as integer, and this would be of type string as stated in the question above. Okay, then in the next part, they're saying the procedure initialize hash table will initialize each element in the array to an empty or null record. Okay, so just a reminder, the hash table is supposed to be 100 rows by 10 columns. So basically it's a 2D array. So we have to use the 2D array syntax for Python now. So write code to declare the global 2D array hash table and the procedure. Okay, so it's global, so it will be at the top of the or the highest scope of the program. And in order to do that, we have to write a procedure. Okay, so let's call it hash table, and it will be initially empty because we have to do it inside a procedure. And maybe let's create it here. So define, or let's do everything in
what
one
is
class.
the
Okay, so moving on, the next thing we have is part B. Okay, so we have to initialize it. So let's hide this class so we don't accidentally indent inside the class. It should be outside. So define initialize hash table like this. And then since hash table is a global variable, so first we refer to that, and then we say hash table is equal to. Okay, so we have to initialize each element to an empty or null record. Okay, so what does null record mean here? So the records are supposed to be like this. So each record would be like this record, and it's supposed to have a key value. First one would be the key value, which would be an integer. So maybe it could be -1, and the other one would be a string. So it could be an empty string like this. So this would be the initial form. So let's maybe create empty record here, or you can do it directly without creating a variable separately for it. Record -1 empty string. So here we get the key, and here this is the data item. And okay, so then we have to create the hash table. So we'll use the 2D array syntax. We'll say empty record, and this would be repeated for I in range 10, and then this whole thing
can
will
you
be repeated.
explain the empty
So this will end up creating 10 empty records. And now because we have to create the 2D in this format, so we have to repeat this thing for 99 rows. So we need to wrap this inside another square bracket to define that this is a 2D array, and then this should be done for 100 times. So maybe for R in range 100, and maybe we can just change this to for C in range 10. It's for column and for the rows. And again, you don't need to do it separately. You can just do it here, but this would be a bit more confusing. So that's why I ended up creating another variable for it. And that is it. So this is our initializing function or procedure. Okay, then they're saying create the function hash. Okay, so let's hide all of these that as we're writing them. Okay, so we have to define a function hash. Okay, now what will hash do? So hash is supposed to take a key as a parameter and it will return the hash value, and this is just a simple function. So we will take a key as a parameter and then we'll just say return key modulus by 100. Let's make it uppercase key because we also have uppercase key in the record. It's just for consistency, you can just change the name, it doesn't matter. Okay, then we have the insert data procedure, which takes an object of type record as a parameter, calculates the hash value for the parameter, and then store the parameter in the correct location. Okay, now before we do this, let's actually test and see what will happen. So all these records that are empty right now, their key values would be represented by a -1, just like we did here. And then their data would be represented by a space. So what we have to do now, first of all, they're saying that you have to insert the data. That means you will take a record as a parameter. Okay, so that record will have some sort of a, it will have some sort of a key and some sort of a data. Then we have to calculate the hash on the key value. So let's say whatever the key value is, and the hash we get according to that is maybe 3, right? So if the key comes out to be 3, now we have to store some data there. Now we go up to our 2D array and we see that there is already a record at index 0 of our third row. So we cannot store here. So we keep on going forward until we end up finding the space. And the condition for finding the space would be, so condition for space would be that the data value would not be equal to -1 because the key value would not be equal to -1 because that is the condition that we initially set here, not equal to -1. Where did we set this? This is here we set it because we said that any empty record would be denoted by a -1. You can make this -99 here, and then you'll have to change it -99 here. So in simple terms, this is just a linear search that will be done for all the 10 columns that we have in this question. And we would not go to all the 99 rows because when we calculate the hash value, so they're saying it will calculate and return the hash value of the key field, right? So in hash tables, what happens is the hash value is basically the index at where we stored the value in. So if the hash value is 3, that means we go to row 3. If the hash value is 0, that means we go to row 0. If hash value is 1, that means we go to row 1. But then afterwards where we go, that is a simple linear search until we end up finding a value, a record, where the key is not equal to -1. So that is the idea. Okay, so let's start and write this. So this is the hash function, this is the initialize. All right, then the next part we're writing is define insert data. And they're saying take an object of type record. So maybe let's call it new record or whatever you want to call it. So new record like this. Then we have to global the hash table. Okay, and then they're saying that first of all you have to calculate the hash value for the parameter using the appropriate function, and for that you have to use the hash function. So it would be, let's call it maybe the current index or whatever you want to call it. Index is equal to hash new record dot key like this. So what will this do? Whatever the new record is, so let's assume just for this example the record is something like this. Record is 88 and the data values may be test value. So what will happen is we are going to send this 88, we're going to get this key out and we're going to send it into our hash function, which will be 88 modulus 100, which would return you essentially 0, I believe. 88 modulus 100 is 88. Okay, so it would return us 88. So 88 would get stored at index. Okay, so this is what we're supposed to do. Now we just get the index out, and just like we discussed before, this would be the index. This would be the row number that we're getting. And now to get to the right column number, we just have to iterate for all the 9 columns until we end up finding the right point where we can insert the value and we can just break the loop there. So let's run a loop. So for I in range, or maybe for columns, for column in range of 10, which simply means this will run for the first 10 values, that is 0 to 9. And every time we have to look at each record stored there. So let's do that. So we'll compare the current key that we got here. So maybe let's say current key is equal to hash table that we're getting current, and maybe let's call it row for consistency, okay, instead of index. So hash tables current row that we got against the current column, and let's get the key out. Okay, so what are we doing here? So like I said, if the row is 1, like this row 1, so we are saying start from column 0 and check row 1 column 0, what do we have? Do we have a record here? Yes, so it will have some key. Then it will go to column 2 column 1, so it will also get the key here, and these key values would not be equal to -1, so that means they are consumed. We cannot store the value here right now, and that is what we're going to check. So we're going to check if the current key is not equal to, is basically equal to -1, which means that the space is available, right? So and if this record is not stored, it's just empty, that means we can store the data here. So we have found an empty record, and so on that empty record we'll just go ahead and put our whole record, new record. So we'll say hash table current row current column is equal to new record, like this, and we put the new record there. So whatever our new record is, let's say our is this new record, so it will get stored at column number 2, and because we have already placed it, so we can just break out of the loop. We don't need to look at all the remaining columns, or even if you don't break, that is completely fine, but break would just make it a bit more efficient because we don't have to loop through multiple times without any reason. So with this, what are we doing? We are just getting the current hash value out. We are going and checking, is there any record already there? If it is there, we are not going to store it, and we are going to keep going through all the columns one by one until they find a column where the key value is -1, and we store it there. That's it. You can assume there will be no more than 10 objects that generate the same hash value. So again, we have used the loop, and simple enough. All right, then we are moving to part A. So let's try that. We have defined part A, which is read data. Okay, opens the text file and reads each line, and then split each line into the key and data. Okay, so we don't have any parameters here, right? Opens the text file and reads each line. Okay, so hash table data.txt stores 200 key values. Okay, let's see if we have this. Okay, yes, we have this file here. So it has some data here. It has the keys separated by a comma, and then it has the values written here, which are the data values. So there are some random words here: adjust, fireplace, exit, bubble, etc. Okay, so they're saying there are 200 values here in this format. For example, the first row is this, so the key is this and the permission is this. So instantly know that you have to use the split function, where we'll split on the basis of a comma, and then we'll get two values out, a list of two values out, and at index 0 we'll get the key, and at index 1 we'll get the data. So we know this by now. We have done many examples related to this. Okay, so then the next thing we have is they're saying open the text file and read each line. So let's do that. First of all, we have to use global hash table. So try. So first of all, we're going to try, and in try, what we're going to do is we're going to open the file. So f is equal to open. The file name is hash table data.txt, and we're opening it in read mode. You can just write R, or even if you don't write R, it's fine. By default, it would be opened in read mode, and then you eventually have to close it. Don't forget to close the file, you lose the mark. Okay, so for line in file F, we will just print line with the strip function, so it removes any empty spaces. I'll just do the remaining part in a bit, and let's write print file processing error, and this should be in quotation marks. And let's get rid of this, and also let's get rid of this. Okay, and I'll just run the read data right now because it's not linked with the main program. And if I run it, so we should get the values here. Okay, it says read data is not defined. I missed the A. Yep, we get the file, right? Okay, now we just have to split the values on the basis of a comma, and then we are supposed to store these. So let's say this is the current item, or maybe the current record is equal to line dot strip, and from this record we are going to get two values out, so we're going to split this record. So maybe items is equal to, we don't need to, well, item is equal to record dot split this on the comma, like this. And then we are going to get our properties out. So our key would be like this. It would be on items index 0. This would be the key value, and then we'll get the data value, which would be at items index 1, and this would be the data value. Again, you don't need to add the comment. This is just for your convenience. Okay, once this is done, we can just store this using the insert function. So they're saying call the insert data with an object containing each key and matching data. So we'll just say insert data key comma data. Now another thing worth remembering here is that all data stored in files is in string format. Okay, so whenever you're reading the data out of a file, you need to convert it into the appropriate type. So we need to convert this into an integer because key is always going to be an integer. Once we have done this, we can add the values. Okay, I think there's no, okay, it's supposed to be a record type. So insert data is going to take a record, so we need to make a record here. So before we do this, this should be in the record class. Okay, so because we're creating an instance of class record, which will take a key and the data, and that's what I've done. If I do it simply, it means you're just making a function call to insert data with two parameters. If I do this, it means I'm making a call to insert data with the record object that has been created. Okay, and before we do this, let's also print them on the screen just once so we know for sure that this is working correctly. Okay, so it only prints one value and then it exits for some reason. Okay, so let's see. All right, so if we call it, so it would not work because we have to call the initialize hash table as well, but that is done in the next parts. So we'll get to it in a bit. All right, so we have done the insert data function here. Then the next thing we are asked is read data. So we've done read data as well. Okay, now get record. So let's hide this and let's try define get record. Okay, now in the get record, we'll just be accessing a specific record and we would be returning that on the screen. So it is saying they take an integer key field as a parameter. Okay, so we'll just write key here. We're going to globally access our hash table, calculate the hash value for the key field using the appropriate function. So we again do that using the hash function on the key, which we wrote above this hash function. So I'll hide all of this. Okay, then they're saying searches the hash table for the record with the matching key field. Okay, now what does this mean? Again, so we have found a specific row here. So let's say the row is 3. Now there are on row 3 there are 4 records stored. So we are just supposed to go through all of the records until we find the record with the key value that we're looking for. So again, a simple linear search will say for column in range 10, and let's get the current key out just like we did before. Hash table current row current column dot key. So there would be some key for this record, some key for this record, some key for this record, etc. And then we have to match it against the key that you're looking for. So if the current key is equal to the key that has been passed, or let's call it target key, just like we do in linear search. So if the current key is equal to the target key, then that means we have found the key that we're looking for. So we are not supposed to return the whole record. We are supposed to return the respective data. So just like it says in the question, returns the data for the record if the record is found. So we'll say return the hash table current row current column dot data like this. Just like we got the key out. So here we'll return the data, and they're saying return not found if the record is not found. So once the for loop ends, it is guaranteed to return us not found in case this condition never becomes true. So this return value would never actually be triggered. So this is done. And then in part G, they're saying load. Then in the main program, we are supposed to call the initialize hash table read data. Okay, it takes 5 integer key fields as input from the user. And then we are supposed to add those into the hash table. So let's run a loop 5 times for I in range 5. And then we are supposed to get 5 keys. So 5 is equal to int input, enter a key value maybe. And then we are going to get the record out for each key. So we'll get the record out. So print get the record out for each key. So basically what we're doing is, since we have the file here, if I'm looking for the key, let's say 316, so it is supposed to return me retreat. If I'm looking for key 578, it should return me private, etc. This is what the idea of this program is. And then we are supposed to run it. Let's see.